Thank you. Good afternoon, everybody. So my work is, so the title is long, but what it is about, the core of it is about playing, tinkering with our palette as a way to learn about design and how to tap it into the FDA design control process. So on the right-hand side, you'll be able to see an infographic about 5 of the important steps of the FDA design control process. Design and development planning, design input, how does it affect the design output? How do we do the V&V process and the design review, the history file? Honestly, some of these are quite dry when you talk about it. And so this is coupled with the senior lab. So I noticed that some of the beloved component of lab will be biomechanics, playing with bones, and some of the electronics instrumentation. So I marry both the two things together. So the students are playing with our palette. So on the right-hand side, our palette are the regurgitated mass that the owls ate. So those unfortunate little critters, you should be able to retrieve their bones. So what the students are doing is part one, they do some design development planning. They look at what kind of creatures they will be able to reassemble from the owl palette. So they do some initial measurement, flexibility, and go through the design process to think about what kind of assistive devices they would have imagined. So part two, design input, you will be able to see some creatures that the student reassemble using foam clay together with the bones that they're able to retrieve. So they come with different monsters, creatures, critters, and then in the design output, they are using different type of CAD design. They are also doing a lot of 3-point mechanical testing, and the interesting thing about it is we try to make it a capstone-like experience, culminating design experience for the students. So obviously, the bones are so tiny and small, they are not able to use a legitimate tabletop machine to do so. So they were asked to actually use Arduino and pressure sensor. They have to do all the body measurement, and they have to 3D print a 3-point testing device and coupled with sensors to really measure the 3-point testing, the stretch strain curve, and to do different types of mechanical tests to support their claim to see if the design input and the design output are in good alignment with each other. So the students are having really a lot of fun because they feel like it is a true marriage of instrumentation, biomechanics, and 3D printing that they've been learning in various other courses, and these concepts and skills and techniques are now married to the different steps in FDA design control. And they also learn about the verification and validation steps, the VMV. So if they're making a wheelchair, how does it work? If they're making a load-bearing device, they're also doing some stress analysis. So all in all, it is a very much capstone-like design experience that marries many of the skill set that they learn about in other classes and put them together. And finally, they're doing the design history file, the final deliverable, device specification, and test results. So after this, the take-home message is it is a month-long project in the senior lab, and coincidentally, they're also starting in the 4th semester of their senior capstone design. So they really appreciate it. They were like, "Wow, I have a much better understanding about not just the design process, but now the downstream regulatory pathway in terms of FDA. What are being entailed." Um, so one thing I really want to talk about, the take-home message about it is this project is a really beautiful marriage demonstrating the interconnectedness of BME. So when we are solving these different problems that are all intertwined together, this project itself is super chaotic. At the beginning, the students are scratching their head. They have no idea how do they even relate to each other. But at the end, it became clear to them, wow, a complex biological system could be quantified using these quantitative measurement techniques. And those could be verified and in compliance with those FDA regulatory pathway. And that's all for my presentation. Thank you.